As you started the recording?
No, Dhruv, I am not started. It's
I
a
only started. I only started, Dhruv.
Okay. But today
Mahesh is
I don't see an option to pause or
Uh,
stop.
I didn't give access to you. Let me give you access. Okay.
Yeah. So for now, just stop it. Okay, and
Yeah, yeah,
then
okay.
we will do a fresh recording then. Okay.
Yeah, yeah. I'll do. Don't forget to record on the while recording. Record in the cloud. Okay, you'll get two options:
Yeah.
local and cloud. Okay,
Okay.
so
Okay.
then
Fine.
no need.
Okay. So yesterday we saw some of the things like how do we start up a database instance and how do we shut it down. Okay. But while doing those things, we didn't discuss the various stages that the instance goes through while starting up or shutting down. Okay. We didn't discuss those things in much detail yesterday. We will do that today. So let me know when my screen is visible.
no, Dhruv. Oh, yes.
Yeah, it should be visible now, right? Yeah, fine. Okay. So let's connect to the database first. So this is the Putty software that we use for connecting to the Oracle database remotely. Okay. It's a command line tool. Okay. So we have connected to the server now. Now, if I want to check whether the database which is created on this system, whether that is running or not, we check that using this command, right? ps-ef pipe into grep p1. Okay. So here you don't see any database instance running. This is the default one that the command is showing. Okay. So if I want to start the database, or say first I want to find out how many databases are created on this server. Okay, so we get that information from this file /etc Ora tab. Okay, now in this file /etc Ora tab, the entries are like this. This is the instance name and this is the Oracle binary installation location. Okay, your Oracle software or Oracle binary has been installed on this location. Okay, so this path is represented or this path is put in this file as well. Okay, /etc/Ora tab. So if I want to connect to this database instance DB1, what I do is I give this dot space Ora env. Okay, so now this will ask me out of all these database instances, which one do I want to connect to? Okay, so I'll say DB1. Okay, now when I want to actually connect to the database as sys DBA, which is the user with highest privilege, we fire like we do this SQL plus / as sys DBA. Okay. When I fired that SQL plus / as sysdba, it tells me connected to an idle instance. That is because this DB1 instance is currently not running, right? It is not running. That's why it gives you this message, connected to an idle instance. Now you want to start it. Okay. So you can give this command like startup. Okay. We saw this yesterday.
Yes.
Yeah. Now, again, if I say come out of this session and I try to connect to the database, now it is not showing me that message connected to an idle instance, correct? Because just now we started it. So when you get this kind of message, it means that your instance is not up. Okay. You need to start the database instance. So that message is a pointer, or it is an indication that the instance is not up. Okay. Now, we said that when you start the database instance, okay, you can check various details regarding the database, okay, like the name of the database, on which date it has been created, how many users are there in the database, all that stuff. So all the information regarding the database itself, it is stored into something called as the data dictionary, right? We discussed about one of the data dictionary view, that is, say, v dollar database, right? So from this v dollar database, yesterday we checked a few details like the name of the database, on which date it was created. Okay. So some of the database data dictionary views, and similar to the data dictionary views, we also have something called as dynamic performance views. Okay. Let's just discuss about those as well. Okay. There is something called as data dictionary views and dynamic performance tables. Okay. So your database metadata is consisting of these two parts. First is data dictionary views, and the other one is dynamic performance tables. What is the difference between these two, and what kind of information is stored inside this specific category, and what kind of information is stored inside the dynamic performance tables? Okay. So first thing first is, these data dictionary views, whatever tables that you will be seeing inside this category, that is data dictionary views, their names will be starting with, say, DBA underscore, okay, or user underscore, or else all underscore. Okay. So if you see any table by the name, I mean, if the name is starting from DBA underscore, or else user underscore, or all underscore, that means it is part of the data dictionary views category. Okay. If you come across any table whose name is starting from V dollar, okay, that means that is part of the dynamic performance tables. Okay. Now, what are dynamic performance tables? Say, if you want to fetch any information regarding how your database is performing at this current point in time, or if you want to see the performance details of database for a previous point in time, okay, someone might ask you that how your database was performing between 9 a.m. and 10 a.m. yesterday, or between, say, 10 a.m. and 11 a.m. couple of days ago. Okay. So you actually want to see the performance related data. Okay. How your database was performing at a given point in time. So those information we will get from various tables which are starting from V dollar. And that's why they are categorized under dynamic performance tables. Okay. So how does these dynamic performance tables differ from the data dictionary views? They, because so that is pretty much based on what kind of information do you see inside data dictionary views. Okay. So data dictionary views are not going to give you any information which you get to see from which you get to see in the dynamic performance table. So dynamic performance tables are pretty much for performance specific data. Getting it?
Yes, Dhruv.
Okay. However, if I refer an example, say in this case, DBA underscore users. Okay, DBA underscore users. So this DBA underscore users will give me the details of all the users who are existing in the database, on which date their account was created, whether their account is currently active or their account is logged. Okay. Now those kind of information, we can't say that it has anything to do with the database performance, right? The user related information that can't be categorized as anything to do with the performance of the database. Getting it? Okay. So here we will just query the DBA underscore users view as well once. Okay. So this is a data dictionary view. Okay. DBA underscore users. And this is a dynamic performance table. That is, its name is starting from $.
$.
Database. Okay. So similar to $. Database, there will be hundreds of other dynamic performance tables that you will be accessing. Okay. We will see them as and not when we go ahead in the next sessions. Okay. So we are coming to the startup and shutdown stages of the database. Okay, so at this moment, if I want to identify whether my database instance is up and running or not, what I can do is I can make use of this query, say select name, comma, open underscore mode, comma, yeah, from $. Database. Okay, so it is saying that the name of the database is DB1 and it is currently opened in read-write mode. Okay. Now let's say that I shut it down. I say shut down immediate. Okay. So you see these stages that your instance or database instance goes through when you fire this shutdown command. It says database closed, database dismounted, and Oracle instance shut down. So these are the stages it has gone through. Okay. So basically, there are various methods or various commands to shut down a database. Okay. We will go through each of them and what happens, which phases it goes through with each of those options. So the first and foremost is shutdown normal. Okay. Or else you just give a shutdown. You just fire shutdowns. It means shutdown normal. Either you fire shutdown or you fire shutdown normal. It both means the same thing. Okay. The other option that you have is you can give shutdown transactional. Okay. The next option that we have is shutdown immediate. Okay. And the last one is shutdown abort. Okay. So these are the 4 ways to shut down your database instance. Okay. Now let's go through each of them in detail. See the first method when it says shutdown normal. So what happens in case of shutdown normal is if sorry, if you as a DBA in your session you have fired a shutdown normal command, that means no other user in the database can connect to the database now. I mean, a new connection cannot be established in the database. Okay. If the DBA has fired a shutdown normal command, no new connections will be allowed in the database. Clear with that? As
Yes, Dhruv.
yeah. However, next point, if you see, it says the Oracle server waits for all users to disconnect before completing the shutdown. So if say that you as a DBA, you fired the shutdown command at say 5 o'clock. Okay. So definitely after this time, Oracle is not going to allow any user to start a new session. However, what about all the users who are already connected to the database? Okay. So Oracle will wait until and unless all the users, they themselves, they exit from their session. Okay. So it might mean that the last user who logs out of the database, he logs out at next day, say 12 p.m. Okay. Next day, 12 p.m. So the database will shut down only after the last user has logged out. Now, whatever time that last user logs out, it will have to wait until then. Understand
Okay.
that? Okay.
Anybody in that is connected to that one until it doesn't shut down.
Exactly. Exactly. No other new connection can be made. However, it will wait for all, it will wait until the last user has logged out.
Yeah.
Okay.
Hmm.
The next thing that happens is the database and redo buffers are written to the disk. So in our database architecture diagram, we saw the database buffer cache and redo buffers, right?
Yeah. Yeah.
So all the contents of the database buffer cache and the redo log buffer, it will be written down onto the files. Like in case of database buffer cache, the dirty buffers will be written down onto the data files. And in the redo buffer,
Redo log files.
log writer will write the redo entries from redo buffer to the redo log
Redo log.
files. So that will happen. Okay. Next, it says that all the background processes will be terminated. Rest of the background processes like PMON, SMON, CKPT, MMAN, M1, all those background processes will be stopped. Okay. And then the SGA is removed from the memory. In the architecture diagram, we saw the SGA, right?
Yeah. Shared global. System
Yeah,
global name.
exactly. So that SGA will be wiped off from the memory. This SGA that you see over here, it will be wiped off from the memory. What next will happen is, after that, Oracle closes and dismounts the database before shutting down the instance. Okay, we will discuss about this step more. When we actually see the steps for starting up the instance, that time you will understand the meaning of this specific point. Okay. And then it says the last thing happens is the next startup does not require an instance recovery. Okay. So if you have performed a shutdown normal, which is also called as a clean shutdown in the database, at the next startup, there is no requirement of an instance recovery. Okay.
Yeah.
Then other database shutdown option that we have is shutdown transactional. Okay. So what happens in case of shutdown transactional and how it differs from shutdown normal? Okay. So in case of shutdown transactional, what will happen is, uh, of course, it will not allow any user to start a new connection. That will definitely happen, as it happened in case of shutdown normal as well. Okay. But at the same time, all those users who were connected to the database, even they cannot start a new transaction. Okay.
Okay.
So what do we mean by that? What exactly is a transaction in the database? Whenever the user fires a DML command, the first DML command, say he fires an insert into T1 values. Okay. So and so. Okay. Then he fires update command. Okay. Then he again fires say some insert command. Okay. So when the user first fired this DML statement, so at the time at which the user has fired a DML statement, the first DML statement, we say that a transaction is initiated. Okay, a transaction has been started. And when exactly that transaction gets completed, it gets completed when the user either fires a commit,
Commit or
or else the user fires a
rollback. Rollback.
rollback. Okay, so this is the lifetime of a transaction. The lifetime of a transaction is starting from the point the user fired the first DML statement. That's the time at which a transaction is started, and it gets completed when the user fires a commit, or else a rollback happens. Okay, or else the user fires a rollback statement. Getting it?
Yeah.
So what will happen in case of shutdown transactional is, say if this user U1 was connected to the database, whatever is the transaction that the user was doing at that time, Oracle will wait for that transaction to complete. Okay. As soon as the transaction is complete, okay, the user will be automatically logged out.
Okay.
Getting it?
Unless wait for a completed transaction.
Exactly, yes. So it has to wait for the transaction to complete. Now it might happen that the transaction gets completed after 4 hours.
Yeah.
Right? In your database, you will have jobs, transactional jobs that will run for 2 hours or 4 hours, right? So
Yeah.
if we take that example, in that case, if the user has fired, if the DBA has fired a shutdown transactional command, the database will not shut down until and unless that transaction is completed. However, as soon as that transaction is complete, the user will automatically get logged out. Okay. Also, what will happen is, after firing the shutdown transactional command, this same user, although he was connected to the database, he was running a transaction, but he cannot start a new transaction. Okay.
Sir, I didn't understand this one.
See, I'll explain again. Let me close this one here. So it says that no client can start a new transaction on this particular instance. Okay. The next one is, a client is disconnected when the client ends the transaction that is in progress. Okay. You understood?
I mean,
these two?
one new user can't connect that one.
Yeah, that happens in case of shutdown normal as well, right?
Yeah.
Okay. In case of shutdown transactional also that will happen.
Yeah.
Okay. The next thing that it says, a client is disconnected when the client ends the transaction that is in progress.
Yeah.
Okay. Then when all transactions have finished, a shutdown immediately occurs. So as soon as all the transactions are completed for various users, your database will automatically get shut down, because the users will automatically be kicked out of the database, right? As soon as their transactions get completed.
Yeah.
Okay. So that happens. Okay. And then again, like it mentions in case of shutdown normal, that the next startup does not require an instance recovery. This also, it does not require an instance recovery at the next startup. Okay. So the primary difference between these two methods is this, if you see. So no client can start a new transaction on this particular instance. Okay. Here it said that it will wait for the users to log out by themselves. That means the user, in their existing session, the users can keep on starting new transactions. In case of shutdown normal, in the already connected sessions, the users can continue to run multiple transactions. They can continue to do whatever tasks that they want to do until next couple of days also. Okay. But in case of shutdown transactional, what will happen is, the user will not be able to start a new transaction. Their existing transactions, Oracle will wait for those transactions to complete, but no new transaction they can start.
Yeah.
Got the difference?
Yeah, I got it.
Yeah. And the other differentiating factor was in case of shutdown normal, Oracle waits for the user to log out. In case of shutdown transactional, it
Transaction
automatically
completed.
logs the user. Yeah. As soon as transaction is complete, the user will be kicked out. Okay, those are the two differentiating factors between these two methods. Okay. The next and most widely used method is shutdown immediate. Okay. Why I say shutdown immediate is most widely used is because in industry, if you fire a shutdown normal command, it is really then you are depending on the users, right? Unless and until the users log out, your database instance will not go down, correct?
Yes.
And you don't know when the user will log out, correct?
Yeah.
Even in the
Yes.
case of shutdown transactional, you don't know the user will run their active transactions for next 1 minute, 1 hour, or next one day. Correct. Even if Oracle is going to log them out automatically, but still has to wait for the transaction to complete. If the
Yes.
transaction is not completing for next 4 hours, that means you as a DBA, although you have fired the shutdown command, you are still waiting. Correct. Because
Yeah.
the transaction is not complete. So that's why this shutdown immediate feature is there, wherein what happens is Oracle does not wait for the running transactions to complete. Okay. See the differentiating factor, it is mentioned at the top itself. Current SQL statements being processed by Oracle are not completed. That is the difference between transactional and immediate. Okay. Then it also says that Oracle server does not wait for users currently connected to the database to disconnect. It will not wait for the users to disconnect.
Yeah.
Okay.
First one, like that first one. Shutdown.
Yeah, exactly. However, if Oracle is not waiting for the users to complete their transactions, if it is canceling those ongoing transactions, it has to do a rollback of those active transactions, right?
Yes.
If say the user had inserted some rows in the table, okay, he after firing the insert statement, let's say that the user went on a break, or he got into something else and he forgot to look into this specific session. Okay. Meanwhile, you as a DBA, you have fired an shut immediate command. Okay. You as a DBA, you have fired the shut immediate command. So the database, if it is not going to wait for this specific transaction to complete, what should it do? Okay. What the default in that case behavior is, all those active transactions will have to be rolled back. Okay. The safest thing that Oracle does in this scenario for the running transaction is to roll back all those transactions. We cannot change that behavior. Okay. Getting that as us?
Yeah.
Yeah. Okay. Yeah. So Oracle rolls back the active transactions and disconnects all the connected users. The next thing it does is Oracle closes and dismounts the database before shutting down the instance. Again, you will understand this when we discuss the startup phases. Okay. And then it says the next startup does not require an instance recovery. Okay. The last and most brutal way to shut down a database is shutdown abort. You fire this command, shutdown abort. What happens in case of shutdown abort is you are terminating the instance abruptly. Okay. It is like you are killing any of those mandatory background processes. Okay. So that is shutdown abort. What happens in case of shutdown abort? Aborting an instance proceeds with the following conditions. Current SQL statements being processed by the Oracle server are immediately terminated. Okay. So if the instance itself is getting terminated automatically or not automatically because of the abort statement, That means it doesn't get time to roll back those ongoing transactions. So in case of shutdown abort, you are not giving Oracle the time to roll back the ongoing transactions, which happens in case of shutdown immediate. Okay. You understand here that Oracle will roll back the active transactions. It will force the users out. It will cancel those ongoing transactions. It will kill those ongoing transactions. But at the same time, it performs the rollback as well. However, in case of shutdown abort, even the rollback is not going to be performed. Okay.
Okay.
Oracle does not wait for users currently connected to the database to disconnect. Database and redo buffers are not written to the disk because you are terminating the instance itself. Nothing will happen. I mean, nothing will happen as in no processes can get carried out. Okay. Uncommitted transactions are not rolled back. The instance is terminated without closing the files. The database is not closed or dismounted, and the next instance startup, see what it says. It requires the instance recovery. Okay. However, in all the previous three options, instance recovery is not required at the next startup. But in case of shutdown abort, instance recovery is required at the next startup. And you as a DBA, when you start up the instance after a shutdown abort, okay, who will perform the instance recovery? Which background process performs the instance recovery? Out of all these, which background process will take care of the instance recovery?
CKPT, control files.
No, no, no.
S1,
The
S1.
instance recovery is taken care of by the SMON background process. Okay. So SMON background process will perform the instance recovery, but to be able to do that, what it has to do is it has to read the information that has been written in the control file. Okay. So only after it is able to read that checkpoint information from the control file, it will be able to perform the instance recovery. Okay.
Yeah.
Now let's just try all these three options of shutting down the database.
Yeah.
We had already stopped it. Let's start it first. Okay. You give shutdown transactional, or let's say shutdown normal was the first option. So shutdown normal will always take a little more time, okay, as compared to shutdown
Immediate.
transactional. Okay. Generally, if the transactions are not going to just continue forever, in that case, I mean, shutdown normal will be slower. Shutdown transactional, we can consider that it will be a little faster. Shutdown immediate will be more fast as compared to transactional also. And
Normal.
shutdown abort is like terminating itself, right? So if you see here, in case of shutdown normal, it is still waiting. When we did shutdown immediate, it was quite faster. Okay, see, it is still not yet down. Okay, you will see the difference in timings. It is still not yet down. Yeah. Okay. Let's start it up once again. Now let's do shutdown. Do this, set time on, set timing on. Okay. Let's say shutdown transactional. So we have fired this command at say 21:42 11th at 11th second. Okay, so it took a little more than 1 minute. Okay, in case of shutdown transaction. Now let's see shutdown immediate, if it is faster or say shut immediate. I didn't start this. Okay. Here I should have started these things to show the time. Problem. Startup. Okay. The last option is shut abort. Okay. See it completed immediately. Okay. And even the messages here it says in case of all the previous three options, when you fire the
Database
shutdown
closed.
command, it
Database
says
closed.
database closed, dismounted, and instant shutdown. This one here it straight away says Oracle instant shutdown. Okay, it has not done these things like database closing, dismounting, all that stuff. Okay, so these are the various options. We generally don't fire this shut abort option. Okay, generally we don't use that option. We in industry we prefer to go ahead with the shutdown immediate. Okay, so another option is there will be some situations wherein you as a DBA you will not be able to connect, even you as a DBA also you will not be able to connect to the database instance. Why that might happen is because your system is so, your server is so heavily used, okay, that even to start a normal connection, one session also, it doesn't have that much amount of resource available. That is, your process is completely utilized, your memory is completely, totally utilized. Okay. So in those scenarios, it might happen that you are not able to connect to this SQL plus prompt, SQL command prompt that you see over here. You are not able to connect to it. Okay, if your system gets heavily loaded. In those scenarios, you might need to still bring the database down. So question would be, how can we stop the database if we are not getting this prompt itself, right? We fire any command in case of Oracle database from the SQL prompt. But if you are not getting this SQL prompt itself because the system is so heavily utilized, how do I shut it down? What I'll do in that case is, you see this pmon process for this database instance db1, which we have been using. Okay, you can kill this process. If you kill the pmon process for this db instance, your db instance will automatically get terminated, and that is as good as firing a shut abort. Okay,
Okay.
so how do we kill that? I'll
Kill or
say kill -9 and then the process name, sorry, process number. Okay, so in this case the process number is 5105. I killed that. Let's see if what does it show. It's not there. Okay, and now if you try to connect to the database instance, see it says connected to an idle instance, but we had actually started it, right?
yeah.
We had started it, we killed it, but prior to killing we had started it. So if you kill the pmon in the pmon process, that means you are, it is as good as killing the instance, terminating the instance by shut abort. Okay,
This is the
so
best
now,
one. You can kill this session using shut abort.
if possible, if you have the option to kill it, in that case shut abort is still preferred over killing the process from os. Okay,
Yeah.
so when you kill the instance, okay, either by killing the pmon process or by firing a shut abort, we said that internally the smon background process will perform the instance recovery at the next startup. Correct?
Yeah.
Now we
Yes.
have performed, we have started the database, so internally smon should have performed the instance recovery. How do we
Okay.
verify that? Okay, how do we verify that? So now we are looking into something called as the background trace files in the database. Okay,
Okay. Um,
okay. So there is this location in your database server which is going to hold one of the most critical trace files for Oracle database, which is called as alert log. Okay, so all the critical events that takes place in your database, they will be logged into this alert log file. Okay, now if you open this file, okay, you see here it says completed crash recovery,
yes.
right? So what I wanted to say is we can go through all those events that are happening in the database internally by reading this trace file called as alert log. Okay, it is the trace files that we use for identifying what all things are happening in the database in the background. Okay, if you want to find out what all critical errors that happened in the database, we go to this alert log file.
Okay.
Okay.
Mm.
You see here it says beginning crash recovery. And then this last one wherein it says that completed crash recovery. Correct? So this is how the recovery has happened in the background and its entry is present in the alert log file. Okay. Yeah. We will keep accessing these alert log files and other trace files from time to time. You will see in various scenarios. Okay. So these are the things that happen when you shut down a database by either of those four options: shutdown, normal, transactional, immediate, and last one is shut abort. Okay. Yeah.
Yeah.
Let's see now what happens when you start up the database and what are the options for starting up the database. So currently your instance is already up. I'll just say set time on, set timing on, and I'll say shut immediate. Okay. Let's see how much time it takes. Shut immediate. See, it is just a little quicker than the shutdown transactional and shutdown normal.
Yeah.
Okay. But this is when any users are not connected to the database, transactions are not happening. Okay. So here in this environment, you will not notice much of a difference between either of those methods. But in industry wherein hundreds of sessions are there in the database, there it makes a huge difference if you mistakenly just fire the shutdown command. Okay. You forgot to add immediate. Okay. If you just fire a shutdown command, by default, it will take shutdown normal. Okay. So let's say that you fired the instead of shutdown immediate, you mistakenly fired only the shutdown command, shutdown, and you entered. Okay. After that, you are waiting. Okay.
Until users are disconnected, we will wait for that one.
No, so exactly that's what I wanted to say. So what you can do is you can do a control C. I'll show it to you. Okay. What I can do is I can still do a control C.
Control C.
Yeah, I canceled that shutdown operation because I now after firing the shutdown command immediately, I recall that, oh, I was supposed to fire shutdown immediate. Okay. So I canceled it. How I can cancel it? Yeah, any command
Control
like
C.
control
Control
C.
C.
Yeah, exactly. So now after that, I'll fire shutdown immediate. Okay.
Yeah.
So now let's look into the startup phases. Okay, so it says starting an instance includes the following tasks. Okay, so first of all, Oracle has to identify the parameter file which it has to use to start up the instance. Okay, so let me duplicate this session and open alert log as well parallelly. Okay. Okay. Okay, so we had fired this shutdown command. That's why in your alert log file, the last thing that you see is the instance shutdown message. Okay, now let's see what happens. What all messages do you see when you fire the startup command? Okay, startup. Let's quickly open that. See what is happening internally. Okay. So here we get to see this message that, okay, database is open. And meanwhile, lots of messages prompted in the alert log file. Let's just read through those messages, what it says. Okay. You able to see this? It is visible to you, right? Or you want me to increase the font?
No, I'm visible.
Okay, fine. So I'm looking for that last message wherein we saw Oracle instance is shut down. You see this message, Oracle instance shut down complete. This was the last message we saw, right? After that, when we fired the startup command, after that, all these messages were prompted. So it says starting Oracle instance normal. Okay. Then it goes through all the various phases. Here it says dump of system resources acquired for SGA. Okay. It will start allocating the memory for all the SGA components. Okay. Here you see it reads through all the parameters that yesterday we saw inside the parameter file, right? You remember yesterday we saw all these parameters in the init.ora file,
Yes.
right? So
Yes.
it reads through that file first. Okay. Then you see it is now starting all the background process. It says starting background process P1, correct?
Yes.
All the background processes will be started. This MN we saw in our architecture. So many, this PMAN also we discussed, DBW0, LGWR, CKPT. So all these background processes have been started. It started the SMON. So once all these background processes are started, after that, I want to show you another message wherein it says alter database mount. Okay. So basically, when you fire this startup command in the database, okay, when the DBA fires a startup command in the database, internally your instance goes through various phases. The first phase is no mount.
No mount. Okay.
Okay. So at the no mount stage, what is going to happen is Oracle server will read the parameter file. Okay. Now, which parameter file is given the preference? Which type of parameter file is given the preference? Static
SQL.
parameter file or dynamic parameter file?
Dynamic.
Dynamic. Okay. So at no mount stage, what will happen is Oracle server will read that dynamic parameter file and it will need to start allocating the SGA in the memory. Okay. It needs to create all these memory components. Okay. All these memory components that we see inside the SGA, all of these needs to be allocated inside the memory. Okay. By reading the dynamic parameter file. Okay.
Yeah.
So if you look at the steps, again, it says reading the initialization parameter from so and so directory. First, it will of course try to find the SP file. If that dynamic parameter file is not present, then it will read the static parameter. Okay. And then it allocates the SGA. Allocation of the SGA means all the memory components will be created. Okay. The Java pool will be created, buffer cache will be created, log buffer, the private SQL area, shared SQL area, all of these will be created. Okay. After that, it will start the background processes. Just now you saw in the alert log file, right? That it starts all the background processes. Correct. Here we see all of these background processes that are getting started. So it starts the background processes in background, and then it opens this alert sid.log file and the other trace files. Okay.
Yeah.
So this happens at the no mount stage. Okay. All of this has happened at the no mount stage. The next stage of instance startup is mount. Okay. So what happens at the mount stage? Your Oracle server will read the parameter. It will read the parameter by the name control underscore files. In your parameter file, there should be a parameter by the name control underscore files, and it will have the names and locations of all the control files that are created for your database. Okay. So again, if we go back to this same trace file, you see we have this parameter control underscore files.
Yeah.
Okay. So this control underscore files parameter, basically it is listing all the multiplexed copies of your control files. Correct?
Yeah.
Okay. So the names and locations of all these multiplexed copies of control files will be read. Okay. And they will be located. Located as in they will be found that, okay, Oracle server will first read this file and it will find that, okay, this file control02 is present on this location and control01.ctl is present on this location. So it goes and it checks those control files, whether those control files are present or not. Okay.
Okay.
Getting it?
Okay.
Yeah. So coming back to those steps. So mounting a database includes the following: associating a database with a previously started instance. Okay. Locating and opening the control files specified in the parameter file. That's what we discussed just now.
Yeah.
That whatever control files are listed under that parameter, all those files will be located and opened. Okay. Then what it also does is, after locating that control file, it will read the contents of the your server, Oracle server will read the contents of the control file. What information does it need from the control file? It basically needs to find the names and locations of all the data files and redo log files that are present in the database. So if we come back to this diagram, we said that this control file will have the checkpoint information which CKPT writes, but at the same time, this control file, these control files will also be having the names and locations of all the data files and redo log files that are present in your database. Okay.
It contains control files contains the location of the data and redo log files.
Yeah, data files and redo log files. That's right. Okay. So your Oracle server will just read the entries of the location of the data files and redo log files at a mount stage. Okay. But it does not go and check whether these data files and redo log files are present or not. It doesn't do that validation that those files are actually present or not. Okay. What is happening at mount stage? Your control file will be read and the names and locations of data files and redo log files will be fetched from those control files, but no further validation is done that whether they are present or not. Okay. So that is what is mentioned here. Reading the control files to obtain the names and status of the data files and redo log files. However, no checks are performed to verify the existence of the data files and redo log files at this time. Okay. So after mount, your database instance moves to the next stage, that is open. Okay. What happens at open stage is at mount stage, it had read the names and locations of data files and redo log files, but it did not check the physical existence. That physical existence check is done at which stage? When
Open
it tries
stage.
to move from, when it tries to move from mount stage to open stage, it will do that physical existence check, whether all these data files and redo log files are present or not. Okay, that is going to happen when instance is trying to move from mount stage to open stage. Okay. Also at that time, what it will also do is internally we said that this checkpoint information is not only written in the control files, it is also written in the data file headers.
Okay.
Okay.
Where
Okay.
okay.
Yeah. So going back to those previous sessions, when we were discussing this CKPT background process, we said that the checkpoint information is written in the control file as well as the data file headers. Okay. So for your database to open properly, for your database to open cleanly, all those data file headers has to have the same checkpoint information. Their data file, the data file headers should have a synced information about the checkpoint number. You're getting it? So what would have, I'll repeat. What would have, if your database was shut down cleanly, this CKPT process, what it would have done before the shutdown, it would have written the checkpoint information, final checkpoint information in the control file and all the data file headers. How so? Whatever is the number of data files present in the database, every data file will have a header, and that header will get updated with the latest checkpoint information. Okay.
Yeah.
So for your database to open successfully, cleanly, okay, the data file headers has to have that same checkpoint information.
Okay.
Okay.
Previously, when setting the checkpoints, whatever they written in the control file, comparing those one.
Exactly. It will, that information will be compared when you start up the database instance. Okay. Okay. So that check is also done when your database is trying to move from mount stage to open stage. So two things happen when the instance is trying to move from mount stage to open stage. First thing is it will now check the physical existence of these two file types, data files, all the data files and all the redo log files. And then it also checks whether all the data file headers are in sync with each other or not in terms of the checkpoint information.
Okay.
Clear?
Yeah.
Yeah. So let's just go through it again. See, opening the database includes the following tasks, that is opening the online data files and opening the online redo log files. Those details are not mentioned over here, but that's what happens internally. Physical existence check and matching the checkpoint information in the data file headers. Getting it?
Yeah.
Okay. So now there are various ways to start up the database instance. The first one is this startup that we have been seeing, we have been using until now. Okay, straight away fire the startup command. Internally, it will go through the no mount as well as the open stage. Okay. Now we will see the various stages manually if we want to take the instance to a specific stage.
Hello?
Yeah, tell me.
Yeah. No.
Okay. So I can say startup no mount. Okay.
Yeah.
Let's just see in the process. Okay. See. So here we have got the SQL prompt back. So that means now your instance has been started. The instance is at no mount stage. Okay. So no mount was the first stage of your instance startup. After no mount, it has to go to the mount stage as well. Okay. So for that, what we have to do is we fire this command alter database mount. See, you have fired the alter database mount command internally. Okay. See, it says successful mount of redo thread 1 database mounted in exclusive mode. Okay. And here it says database altered. Okay. Next, after mount, it has to go to the open stage. Okay. So then we fire alter database open. See, now it will do rest of the things. Okay. So it says alter, your database is now altered. Okay. Now let's just come, let's do one thing. Shut immediate once again. Shutting down instance, it will have to do all those cleanup. See, what I want to show you now is I can straight away fire this command startup mount. Okay. So if I give startup mount, it automatically goes through the no mount stage and takes the instance at the mount stage. Okay. See, it says database mounted. Okay. Now at this stage, if you want to identify exactly at which phase or exactly at which stage your instance is currently at. Okay. So we have this dynamic performance view, DESC $instance. select status from $v
Instance.
instance. You see here it says mounted because we are at the mount stage. The instance is at mount stage. Correct?
Hmm.
Now,
Yeah.
if I want to move to the open stage, I'll say alter database
Open.
open. Okay. Now, if we fire the same command, this is
Status
open.
open.
Okay. So previously it was showing status as mounted.
Mounted.
Now it is showing the status as open.
Open.
Okay. So this way we can check exactly at which stage our instance is there at that given point in time. Clear
Okay.
with this?
Yeah, yeah.
Okay. So these are the various ways you are going to manage your instance. Like how do we shut down the database instance? Which are the possible methods? What happens in case of each of those shutdown options? Which are the ways to start up the database instance? How many phases it goes through in each of those startup options, right? Okay, so that is about the database startup and shutdown options, and all these events are recorded in the alert log file, which is the most important trace file in the database. Okay,
Hmm.
clear?
Yeah.
Okay, we'll stop for the day and then we'll continue again tomorrow. Okay.
Yeah. Sure. Your